In this demonstration, we show how to deploy a sample WordPress application with a MySQL database backend inside of a Tanzu Kubernetes cluster running on VMware Cloud Foundation with Tanzu. We begin by reviewing the Tanzu Kubernetes cluster in the vSphere client. Expanding the WLD01-NS01 namespace, we see there is a single Tanzu Kubernetes cluster named GC01. The vSphere web client displays details about the Tanzu Kubernetes cluster along with its associated virtual machines. Note, however, that it does not provide visibility to the workloads running inside the Tanzu Kubernetes cluster. To view the deployed applications, we will use the Kubernetes dashboard. From the Kubernetes dashboard, we again see the 4 virtual machines that make up the nodes in our GC01 Tanzu Kubernetes cluster. Clicking on pods, we see there are currently no pods deployed in our Tanzu Kubernetes cluster. Let's deploy the sample WordPress application inside the GC01 Tanzu Kubernetes cluster. Before we can deploy the application, we first need to authenticate to the vSphere namespace where the Tanzu Kubernetes cluster is running. To do this, we run the kubectl vSphere login command and pass in the SSO user credentials along with the IP address for the Kubernetes control plane that is running on our vSphere cluster, along with the name of the vSphere namespace and Tanzu Kubernetes cluster. Here we have successfully authenticated to the supervisor cluster as the SSO user administrator at vsphere.local. Once authenticated, we are presented with a list of available vSphere namespaces and Tanzu Kubernetes clusters for which we have been granted access by the Cloud Foundation administrator. We will set our context to GC01. We have now successfully logged into our GC01 Tanzu Kubernetes cluster. There are 2 ways to deploy pods inside a Tanzu Kubernetes cluster, directly or indirectly. You create a pod directly by deploying a pod spec. You create a pod indirectly by defining a higher level resource, such as a deployment. When deploying pods indirectly, a service account creates the underlying pod. This requires binding a pod security policy to a service account in the Tanzu Kubernetes cluster. This is done using a role binding. This YAML manifest creates a role binding that grants access to all service accounts using the default pod security policy VMware-system-privileged. To apply the role binding, we run the command kubectl apply-f and pass in the name of the YAML manifest. With the role binding in place, we are now ready to deploy our WordPress application. Let's start by checking for any existing pods. We confirm that there are no pods currently deployed. In this example, we will deploy the WordPress application using a Kubernetes customization file. We begin by creating a customization.yaml manifest file in the working directory on our Linux workstation. Inside the customization YAML, we define a secret generator with the password that we will use to connect to the MySQL instance that we will deploy. Along with that, we include 2 additional YAML manifests that will be used to deploy our application, the MySQL deployment YAML and the WordPress deployment YAML. Let's look at the MySQL deployment YAML manifest file. Inside this manifest, we see the resource definitions for the Kubernetes objects that will make up our MySQL application. For example, we see the resource definition for the MySQL service, the MySQL deployment resource, and the persistent volume claim resources. As I mentioned, we also have the WordPress deployment YAML manifest file. Here again, we see the resource definitions for the service, persistent volume claim, and deployment components that will make up our WordPress application. We place all 3 of these files into a directory on our workstation where we simply run the command kubectl apply-k to deploy the application. Once deployed, we can view the WordPress deployment from our workstation using the kubectl commands. Running kubectl get pods displays the pods that have been deployed. Running kubectl get deployments displays the Kubernetes deployment. Running kubectl get services displays the Kubernetes services associated with the application. Running the kubectl get persistent volumes claims displays the information about the persistent volume claims used by the application. We can also view these components from the Kubernetes dashboard. Here again, we see the 2 pods that were deployed, one for the WordPress instance and the second for the MySQL database instance. along with the associated deployment resource. and the persistent volume claims. Again, we see one for WordPress and the second for MySQL. Viewing the service resources, notice the WordPress service has a hyperlink to the external IP address that has been assigned. Clicking the hyperlink, we are connected to the WordPress instance, where we can verify the application is running. Next, we'll remove the application. Removing the WordPress application is easy. We simply go to the directory where we have our customization YAML and run the command kubectl delete-k, passing in that directory name. The output shows the secret, the service, the deployment, and associated persistent volume claims have all been removed. When we rerun the kubectl get pods command, we're able to confirm that the pods have been removed. In the Kubernetes dashboard, we see that the services page has automatically been updated to show the removal of the WordPress and MySQL services. We are also able to confirm that the persistent volume claims have been removed, along with the deployments and the pods. In this demonstration, we saw how to deploy container-based workloads inside of a Tanzu Kubernetes cluster using a Kubernetes customization file. The demo showed the steps to log into the Tanzu Kubernetes cluster, configure role bindings, and deploy the application. After verifying the application was working, we then showed how to remove the application.